This is our company, NanoFlowX, and we manufacture advanced nano coatings for electronics. The problem we're trying to solve, IoT devices and connected space, 5G autonomous is growing exponentially, and a lot of them aren't designed for various protection against the environmental issues you see below. Liquid, humidity, moisture, dust, and corrosion are the key ones. That all affects the durability of the actual PCB electronic device inside. And because of that, the current solutions in the market right now don't offer a true way of protection against these environmental issues. So you end up with a lot of electronic waste, about 54 billion tons per year, and that number is growing exponentially. So we created a electronics nano coating. Our business model is we have a service that we can do the coating in-house, but we prefer to send the solution to the manufacturer or customer and turnkey the entire process. Basically, it's a very easy DIY solution. Benefits, again, you're adding an IP rating to electronics, increasing reliability, product life cycle, decreased downtime, warranty claims, and adding sustainability by reducing electronic waste.
V2's coating is 1 micrometer thin, hydrophobic and oleophobic. It is fully reworkable and does not require masking components or any expensive machinery. V2 has an operating temperature of -76 degrees Fahrenheit and 482 degrees Fahrenheit. Here an iPhone treated with V2 has the screen lifted and submerged underwater and is remaining conductive while still charging at the same time.
So that's the video showing the actual phone underwater as a demonstration, but on top of our actual technology, this blue area here represents a coating, and in the coating we have a patent pending advanced microcapsules that we can fill with different additional chemicals, whether it's our electronics coating, antimicrobial, or a corrosion inhibitor. And at any point the coating is scratched or is worn down, these capsules would pop and release additional solutions to counteract what the customer would want, whether it's a self-healing component or releasing an antimicrobial agent to the surface. Yeah, it's all custom proprietary solution. And we have different tests conducted. We're REACH and RoHS compliant, IP67, 68 testing, a non-flammability test, durability test, all conducted by the largest labs globally. We do have a mil spec as well. And the application process is quite simple. Take your PCB device, dip in our solution for 5 seconds, remove it, and apply heat. The remaining solution can then be poured back into the original bottle and stored for up to 6 months for future use, essentially reducing all waste. But that's how easy it is to use. You can spray it on the device as well, you just have to saturate it enough. And the heating makes it set and cure evenly, is why we apply the heat. Here's the actual video of a demonstration on the iPhone. Dip, drain, heat, and you have a hydrophobic, oleophobic effect on the PCB device. So traditional conformal coating, they're heavy, they're really thick. It takes 30 minutes to coat to mask a motherboard, and they're not reworkable. Anyone who's using electronic devices hate this process. Then you have vapor deposition, which requires a huge capital investment because you have this machine. It doesn't offer a true IP 6.8 rating or 6.7 against dust, non-reworkable, and there's limited devices you can put in there. Anything with a battery is not recommended. It would deform the cells, and anything with a microfoam, it will actually pop the diaphragm. Again, the process is extremely long. So we're kind of the faster, cheaper, easier to use solution now, replacing all the traditional methods and even an enclosure. Again, it can be from $5 to $60, $60,000 of investment, depending on the actual volume of production. Here's a video of the...
Hey Alexa, how's the weather in Spain?
Which city in Spain?
Barcelona.
Right now in Barcelona, Spain. It's 53 degrees Fahrenheit with partly sunny skies.
these are just basic consumer items that we purchased and weatherized. So commercially, we have customers in large ODM, large electronic manufacturers. Also, we just had our first DoD contract late 19 and expanding into that in this year as well. Some use cases for government DoD, of course, IoT devices, UAVs, UGVs, sensors, 5G antennas, since everyone's going to smart technology and more connected devices, but robotics, rugged computers, communications, radios, and of course, medical devices. And that's my presentation.